Morning, guys. So we're going to continue our soil compactions, okay? Okay. So we already covered this. The water content effects, to remember, purpose of water, you want to help particles to move around so that it can get its best back, compactive efforts. As you give more energy, it can increase its dry density, and it can also increase its it reduces compressibility, increases stability, and it also increases bearing capacity. Okay. For soil type shown in our last class, basically for soil type it is only best for sand. Okay. Each and every time when you talk about compaction it is meant for sand. As you can see that, like for clay itself, it won't have that much of a increment. So embankment, okay, embankment is referred to a volume of earth meter is placed and compacted for the purpose of raising above the level of existing surrounding ground surface. And you have another one, fill. So fill refer to a volume of earth material that is placed and compacted for the purpose of filling in the hole or depressions. So you have two. The first one, embankment, you want to raise. So even though you want to raise, you have to compact until you reach the height that you want. Why you have to compact? You need to ensure that this earth, it is actually stable. So another one is fill. Fill is like when you have cavity, or when you have okay, you want to build a house here, and you're going to have a house here as well. You're going to have a house here as well. Okay. So in order for you to be able to have a house in here, of course, you need to fill this hole, right? So when you need to fill this hole, so that's why you need to do the compactions, okay? Okay, so you need to do the compactions. So you have to compact layers by layers, okay? Until you be able to raise to the required depth. Sorry, to the required height. Okay, 2, 3, 4. Okay. So you're going to compact layers by layers by layers until you can get that levels. Okay, so far can you understand the difference between embankment and fill? Can you understand, right? So as you can see that, it is true that compaction can alter the soil to become dense. You have dense, less compressible, less settlements, high strength, and high bearing capacity. However, if you look back into the slide, you would notice that in order to rearrange the particles and reduce the void ratio. So this is actually only applicable to coarse grain size soil. As I mentioned before, sand. Okay, take a sample of the soil there. You can actually know the percent of clay as well as the percent of sand. And in fact, with JKR requirements, they also have requirements on what is the highest value or what is the lowest value that is suitable for compactions. What is the highest value that you should actually apply to the site? Which type of soil that is considered can be used at site, and which type of soil that you cannot do you cannot use that site. Okay, that one is covered in elective course in ground investigation in your fourth year. That is basically dealing with specifications for engineers. So for JKR, they have lots of specification that, as mentioned before, compaction will change soil become more dense. This also prevents water from seep through to the bottom of embankments. And if you fail to do this, then water will seeping down through the embankment, then it will soften the embankment base. Start to have a slope failure, the landslides. Okay, so it is very important each layer of this you do a very well compacted. So if not, then you're going to have like first you have embankment erosions. If it's erosions, somehow it still can be visible. It is, which is why it's very important that you have a proper drainage. So when you have a proper drainage throughout the whole site, you will be able to actually manage the surface runoff of the water. Okay? So when you'll be able to manage the surface runoff of the water, then you can actually ensure throughout the whole sites there will be no soil erosions or a slope failure, embankment failure when you actually do this. Okay, so field specifications. In field specifications, to control the soil property of the earth constructions, okay, it is usually to specify that soil must be compacted to some predetermined dry unit weight. Okay, the specification usually states that a certain of the maximum dry density as found from the laboratory test, standard or modified. If you say 95% standards or 95% modified, so please make sure you understand which sort of test it is referring to, and this one must be achieved on site. Then standard practice normally specify that field density must be greater than 95% of the maximum dry unit weight as determined from the standard compaction test. Okay, so there's wide range of compaction equipment for road construction. So we have wheel, roller, vibrating plates. So this only affect a small depth of soil, and to achieve a larger depth, a vibrating plates and drop weight can actually be used. The applicability of the equipment depends as well as on the soil type. So this one is the equipment, and this is type of compactor. This is suitable soil to be used with this sort of equipment. Fine grain soil with more than 20% fine sheep foot roller. Okay, so this is an example of compactor. So we have so many types of compactor to create a platform level. Okay, so several types of compactor that usually used in the construction projects to ensure well compacted layer and minimize force of surface water. This is referring to surface water runoff. So this is a type of compactor, and this is maximum that they can actually be able to penetrate. Okay, so this is sheep foot. So this one is normal compactor. I believe all of you already seen this one before. This one is normal compactor. This one. Okay, so this is for shallow compactions, and this is what we call for deep compactions. So in deep compactions, you can use actually dynamic compactor. And there's also another technology where we call dynamic replacements. In dynamic compactor, it's actually they're going to raise this steel. You're going to raise this steel as high as, based on the design, it can go as high as 10 meters, can go as high as 15 meters, or even just 5 meters. So one of these steel usually weight around 1 ton, and sometimes 2 tons, depends on the design of the energy that is required for you to actually compact After that, they're going to rinse, then they're going to release, then they're going to compact. Okay, the dynamic replacement is a kind of a methods when you replace the loose soil with rocks. And of course, rock have a higher than capacity and does not compress as like what you have in soil. Okay, so that's actually the ideas. So in compaction, you have two conditions. One is shallow. Shallow means that you have to do compaction layers by layers. Depends on the machines. You have to compact every 300 1 feet, or can go for deep compactions. Deep compaction means you want to treat the soil that already at sites. Okay, so in deep compaction, there's also another techniques what we call stone columns. In stone columns, you're going to penetrate the ground. Okay, once you penetrate the ground, then you're going to replace with the stones. Then after that, you're going to compact layers by layers by layers by layers until it reaches the top. Compaction quality control. Okay, so in compaction quality control, we're going to do a compaction is that you remember that 95%. So 95%, it is actually, if you reach that, then it's considered accepted. If it's not reached 95% and it is not accepted. So how are you going to check whether is it 95% value? It is actually through the test. We have three tests, okay, sand cone test, a balloon test, as well as nuclear density meter test. This is sand cone test. Basically, you have this bottle, you know the volume, the weight of the soil inside that. And we usually use sand. So we usually use sand, and it's not just a typical sand, it must be a standard sand. Okay, so when you use a standard sand, then you know the density of the sand, then the density of the sand as well as the particles of the sand is uniform. So when it's uniform, each and every time when you do your test, is when you repeat the test, the repeatability is can achieve the same value. So that's the purpose of using a standard sand. So most of the time, use any type of available standard sands. You can use Ottawa sand, you can even use Toyura sand. The idea of sand cone is that once you already have this amount of sand, then you actually create a hole. Okay, this hole is based on a value that you already know. So which means that if you want to make a hole of say 15 centimeter, then based on that size, you already know the volume, right? So once you already know the volume, then you can straight away pour the sand. So once you pour the sand, you know that amount of sand inside the hole. So once you already know the amount of sand inside the hole, then you can actually recalculate back again what is the density at site. As well as once you already take this one, then you're going to compare with the soil sample. This one is sand cone test. If you're using a balloon test is also the same. The only difference is that instead of using cone, you are actually put a balloon inside here. So once you inflate the balloon, the amount of gas that you actually inflate the balloon, you can actually know what is density of the soil inside the hole. The most common test is sand cone. Another method is nuclear gauge. So while using a nuclear density meter, so you just actually going to penetrate this one, the source. Then after that, from the source, you're going to release a very small amount of nuclear. Then you straight away going to get the value of the density. Okay, unlike sand cone, you have to actually bring back to the lab. You need to weigh the sand and you need to take a sample. But with nuclear gauge density, so it is very fast. It's straight away you can get the value. Okay, so thank you very much, guys, and okay, thank you. Have a great day today. Okay.